Hi, today we're looking at lab preparation for the Justice Lab. And before you actually start doing your work in the laboratory, there's a few things you need to know. This is what any chemistry student should be aware of. So let me show you some of the things that we're going to be using. Well, if we've come to the conclusion that what we're going to look at is changes in concentration of a solution, we want to look at a possible solution. And to do this, I'm starting off with just some food coloring in water. And it's a pretty concentrated solution, as you might see. So I am going to do what's called a serial dilution. You can come through this dilution process in lots of different ways. But what I've started off with are 6 test tubes for this demonstration. The first test tube was filled with 10 milliliters of water, and then 9, 8, 7, 6, and 5 milliliters of water. Now, I want a total of 10 milliliters total in all of my test tubes. So, since this tube had 5 milliliters of water in it, I've gone ahead and added 5 milliliters of the blue food dye, my starting solution. Since this had 6 milliliters of water, I added 4 milliliters of blue food coloring. 3, 2, and now I'm going to add 1 milliliter of the blue starting solution here. Let me tell you how I'm going to do this. I'm going to use a pipette. Let's take a look at what we have here, which is our pipette, which is a very accurate measuring device. We don't want to use our graduated cylinders or our that are in our drawer. Now, you get your pipette, and the pipette is inserted into what we call a pie pump. The nozzle is down. You have to have a good seal here. If your seal is not good, then it's not going to hold the volume that you want. You're going to take volume in by rolling the pipette up, and then you will eject the liquid in the pipette either by controlled rolling the pipette down, or you could do a push here, but I wouldn't advise the pushing. I would use the roller. I want to show you the difference in 2 pipettes. If you'll look at the screen here, you'll see one pipette. And in this pipette, this is a 10 milliliter pipette, but look at where the 10 milliliters ends. It ends here. This volume at the lower tip of the pipette is not measurable. So if you want to discharge 10 full milliliters, you'd start at the top and go down to the 10 ml line and stop. You would leave liquid in this lower portion. Compare that with the pipette I'm using today. Let me just put them side by side. And you should be able to see here, trying to get them to lay still. Let me turn this one over. You should be able to see here that this pipette is very different. This pipette goes down to 9 milliliters. If you want to eject 10 milliliters of liquid, you've got to include all the liquid in the tip. So I call this a to-deliver pipette. You want to deliver the entire volume here. So make sure you know what type of a pipette you are using to have accurate measurements. Now, let's go and take a measurement. I showed you here that I'm going to put 1 milliliter of the blue food coloring. So I'm going to put the pipette beneath the surface of the liquid. I'm going to carefully read 1 milliliter at eye level. Not easy to do. I'm looking for the 1. And there it is, okay? So I have 1 milliliter of blue dye in the pipette. I'm going to put that into this tube so that my total volume is 10 milliliters. And I'm going to do this by rolling down on the dial. Okay, so now I have my 1 milliliter into 9 milliliters of water. I'm going to take, and I should use some parafilm. I'm in a hurry, so I'm just going to do an inversion here to make sure that my liquid is well mixed. Okay, so now I have all of these dilutions. When you are getting ready to take your measurements, you're going to use a device called a colorimeter. This is our colorimeter. If you can focus in on the numbers here, what you'll see is that you have different possible choices for wavelengths of light that we want to be using. And what we're going to use in this experiment is our last choice, which is, where the green dot is now, 635 nanometers. This has to be calibrated, and we'll talk about calibration in class, because there are two types of colorimeters, and depending on which colorimeter you're using, the calibration might be different. When you open up the colorimeter, there is a spot inside for your cuvette to sit. Let's look at the cuvette itself, because you can see that the opening is square. So is the cuvette. If you look at the cuvette, what you see is that there are two different sides. One side is frosted. There are lines. We do not want the light to pass through in this direction. Instead, we want to use the clear side to our cuvette. When we insert the cuvette into the colorimeter, you can see the direction of the light because there is a white arrow. This is how the light is going to pass through the sample. So we want to take the cuvette with its clear sides and insert it into the cuvette so that the light is passing through the clear sides of the cuvette, not the striated sides, the frosted sides, which would block any light going through. Now, for this experiment, we want to use a certain wavelength, and I told you that we were going to select 635, but the question is why. Let's look at a color wheel. If you look at a color wheel, you would see that the color of our sample is more of a blue. We're using a blue food coloring. So this means that our sample reflects blue light. This means that it absorbs the complementary color, which would be a reddish orange. Looking at wavelengths of light, the reddish orange wavelength would be somewhere around 630 nanometers. So we've made a wise choice. We did not want to use 430 because that's blue. That would be a color we would use if our sample were red. We'll be talking more about this in class. All right, so we're at 635 nanometers. Now let's take a look, and here's what we want to do. We want to take all of our readings, but it's always better to work from the least concentrated sample to the most concentrated sample. So what I'm going to put into my colorimeter at this point is just pure water. I'm using not a pipette like before. I'm using one of our plastic Burrell pipettes because it's easy to squirt the water in. You know that you're not going to scratch the sides of the cuvette, and you want to make sure, I'm going to let you see this one, that when you fill the cuvette, you want it to be 2/3 to 3/4 full. Now, I'm not sure if you can see it or not, but let me tell you this. This is a great AP question. Would these bubbles along the side cause error in our readings? The answer is yes. How would it affect our readings? We've got to figure that out. But if we can get those bubbles to float to the surface just by rubbing the sides of the cuvette with our pipette, we're better off. Okay, I think that's fairly good. So I'm going to put this cuvette into the colorimeter. I'm going to lay it flat down. I'm going to close the door. So I have pure water in our colorimeter at this point. Now, we are connecting this through this cord to our data collection device, which is called the LabQuest. If you'll look at the screen, I'll go through and I'll show you the things that we have to do to set this up. All I've done so far is to turn on the LabQuest. The colorimeter is connected into channel 1 so that it knows, because this is an auto ID probe, it has registered that this is a colorimeter and that it is reading absorbance. How much light is being absorbed? Well, there's nothing in there. It's pure water. So 0 light is being absorbed. We want to record this information. So what we're going to do, since our sensors have already been set up automatically, our sensors could be set up here. Sensors. But since the sensors have been set up automatically, I'm going to go right to mode. And in the mode, I have choices. I do not want to do a timed base mode. So in this top area, I'm going to change from time-based into events with entry. Events with entry. And what I want to do here is name the event, and we'll call it concentration. And so I can simply type in CONC because it's related to our concentration. And I'm going to say OK. All right, so now I am in a mode which is events with entry. I know that might be a little hard to see since I'm showing it on the overhead, on the smartboard. But the reading is 0. So I want to run an experiment. Now, let me remember how to do that. Okay. You see the green button down here in the left-hand corner. I can either tap there or I could tap here. And what appears is a piece of graph paper. So it now reads 0. I'm ready to take a reading. So you'll notice that there is a red button here at this point. I have a value here that I want to keep. This says keep. So I'm going to read this absorbance here, which is 0, and I'm going to say keep this value. And it says penny. Tell me a reading. Well, how much blue dye is in there? The answer is 0. So I'll type in 0 here and press OK. And a mark appears on my graph paper, which you can't see at this point. So now I'm going to change the solution. I'm going to carefully remove the liquid from the cuvette. Replacing it with the weakest solution that I have, the most dilute solution, which was 1 milliliter into 10 of water. Okay, looking for bubbles. All right. Now, since I'm using the red wavelength, you'll notice that you'll see numbers changing here. They'll change for a little bit, and they're stabilizing at about 0.3. So what I'm going to say here was I'm going to keep this data since it's now stable. I'll hit keep. And what I'm going to say here is that I'm going to tell them how many milliliters of the blue dye I put in. So I'll say this is like a 10% dilution because it's 1 into 9. So I'm going to say 10% solution. Okay. Look at the dot that appears here on my screen. Now I'm going to go back to the colorimeter. I'm going to remove the 1 ml into 9, which is my 10% dilution. And I'll fill with the second one, the second solution, which had 2 milliliters up to 10. All right. And we're going to get one more reading. The reading here is increasing to 0.4.